Hello! In this video, we are going to learn about vaults, which is where Robomotion keeps the credentials your flows need. A password does not belong in a flow. Anyone who can open the flow can read it, and every copy of that flow carries it with them. So it goes in a vault instead. Encrypted before it leaves your browser, stored encrypted, and readable by a robot only after you have handed that robot the key. The vault is a surface of the workspace, not part of any one flow. It is on the left rail. And the first thing it wants is your account password. Not the flow's, not the robot's, yours. Being signed in is deliberately not enough. That password is what unwraps your vault key, so a stolen session still cannot read a secret out of here. Inside, a workspace can hold as many vaults as it needs. One per system is the usual shape, because access is granted a whole vault at a time. Let us make one, new vault at the bottom of the list. It takes a name and a description. We will call this one example vault. And this is the part of the video to pay attention to. Creating a vault generates a vault secret key on your machine and shows it to you exactly once. It is never sent to our servers. Nobody at Robomotion can recover it, and neither can you. Lose it and the vault cannot be opened again. The only way forward is a new vault and every credential entered a second time. So copy it and keep it somewhere safe. We are going to need it twice more before this video is over. The vault is created and it is open in this browser. A vault holds items, and an item is one credential. There are 8 kinds, and the kind decides which fields the item has. A login is a username and a password. Email is an SMTP or IMAP account. Credit card is a number, an expiry, and a CVV API key is a token. Database is a connection. Document is anything that is simply text, a service account key file, for instance. And the last 2 are encryption keys. We want a login. Name it after what it opens, because this name is what you will be picking from a list inside a node later. Then the username and the password. This is the last time either of them is in the clear until a robot asks for them. Save. The padlock on the vault is open now, and this browser will remember that key, encrypted, so it does not ask again. The account password it does ask for every single time you open this surface. And on another machine, the vault is locked until the secret key is entered there too. Now the flow. It starts as every flow does, with an inject node renamed to start. After it, the get item node, which lives under vault in the palette. Get item takes one item out of one vault, decrypts it, and puts it on the message. Its output is called credentials by default, so everything downstream reads message.credentials. And a debug node at the end, so we can see what actually arrived. One click on Get Item, and its properties open on the right. Output first. The item lands on the message under the name Credentials, and you can rename that here if you want it somewhere else. Below it, Credentials. This is where a node says which item it means, and it is 2 choices, not 1. The vault. And the item inside it. The list is the names you gave your items, which is why the name is worth choosing well. Then save the flow, because a robot runs the saved flow and not the one on your screen. Let us run it on a robot connected to this workspace. The robot takes the flow, and the nodes light up as it works through them. And it stops on Get Item. The vault is locked on this robot, it says, so the item cannot be read. The vault secret has not been injected. Every item in a vault is stored encrypted. The server holds ciphertext and nothing else, so there is no version of this the server could have handed over. Your browser can read it because your browser has the vault secret key. This robot has never been given it. And that is normal. A robot is often a machine in another building, or a server nobody logs into. It has to be handed the key some other way, which the error goes on to tell you how to do. That other way is the admin console, under robots. Every robot the workspace knows is here, and this is the one that just failed, connected from this machine. Its Actions menu has Inject Vault Secret. Your account password again, because handing out a vault key is a vault operation. Then which vault the key is for, and the key itself, the one from the dialog we copied when the vault was created. And Inject. This screen is safe to use even though the key crosses a network. Every robot has its own key pair, and the browser encrypts the vault secret with that robot's public key before it sends it. It travels encrypted over TLS and is forwarded to the robot on its own connection. Nothing in between can read it, because nothing in between has that robot's private key. This is done once per robot and once per vault. It outlives the robot being restarted, and giving one robot a key gives nothing to any other. Nothing about the flow has changed. Run it again. This time get item comes through, and the debug node prints the whole message. Open the credentials it put there, and the item is inside it. The username we stored and the password masked. The robot has the real one, the console will not print it, and neither will the logs. That is the first of the two ways to use a vault item. Pull it onto the message and use it wherever you need it, typing it into a login page with the browser nodes, for instance. There is a second way, and for most nodes that need a credential, it is the only one. Between getItem and the debug node goes an HTTP request node, renamed to sign in. It calls a public test service that answers only when the request carries a username and a password it recognizes. It does not read a username and a password off the message. It has a credentials property of its own, and it goes to the vault itself. So getItem is only still here because we built it in the first half. If signing in were all you needed, this flow would be start, sign in, debug. Here are its properties. The URL is the test endpoint, and the method is a plain get. Authentication is set to basic authentication, and that is what turns the credentials property below it on, which points at the same vault and the same item. Look at what is not here. No username box, no password box. A credential only comes from a vault, so this node needs nothing before it. Save. One more run. getItem runs first, but nothing after it uses that. And sign in goes to the vault itself, builds the authorization header, and never touches the message at all. The status is 200, so the service let us in. And its answer, in one word. Authenticated, true. A service accepted a username and a password that are written down nowhere in this flow. One vault item reached two ways, and the second way needed neither getItem nor the message. A vault secret key is generated on your machine and shown to you once. Keep it, because nothing on our side can bring it back. A robot needs that key injected before it can read the vault, and that happens in the admin console, one vault at a time. And a flow reaches a credential in one of two ways. getItem puts it on the message, or the node that needs it points at the vault itself. Thank you for watching.